Hi, this is Sam, and I'm doing task number 3, pennies to heaven. I'm going to show the solution how to do it. First, they gave you an information that a penny is about 1/16 of an inch thick. And the first question, in 2011, there were approximately 5 billion pennies made. If all of these pennies were placed in a single stack, how many miles high would the stack be? So they gave you two information. Is that one penny is 1/16 inch of an inch high and 5 billion pennies, which is 5 and 9 zeros pennies. So in the year 2011, it doesn't relevant. It means nothing to the question. The question is how many miles high would that stack be? This is the measurement of time, and this is the measurement of the higher distance. So it doesn't relevant. We will ignore it. So first we have to the question said how many miles high. So we have sooner or later we have to convert inches to miles, and the conversion of inches to miles is 1 mile equal 36630 inches, 36,630 inches. So the next step is we have to change 1/16 inches into decimals, which is 0.0625, and yes, next we will change all values to proper scientific notation, which is using often multiply 10 to the power of n by and the n is the exponent, and it depends, and the high or low it is, the bigger or lower it is, depends on the position of the decimal, and the number here must be equal or larger than 1, but must be smaller than 10. So this is 0.0625, this is smaller than 1. So we have to change it by moving the decimal point. So if we're moving to the right, we must minus the exponent. Let's do the exponent. So here we move right 2 times, which means -2, and here the number is larger or equal than 1, but smaller than 10. And this is called proper scientific notation, and this is written in proper scientific notation. Same goes with this. The decimal point is over here. We have to move over 1, 2, 3, 4, 5, 6, 7, 8, 9 digits, and to the left, which means we have to plus the exponents 9. Same goes with this, to the left, which means we have to plus the exponents. One, 2, 3, 4. So the next step is we will convert the inch to mile by taking this and divide by this. So this is how it looks like. So this is how you should write when we divide it. And we can simplify it easier by we can simplify by these two by, and one way is called the quotient rule. Is we don't need to care about the base keeps the same always, but the thing is the exponent. We bring the exponent of the denominator up and switch the sign, and we take the exponent of the upper minus, like -4, which is right. -2 minus 4 is -6. We don't need it. And 6.25 divide 3.663 is equal 6.25 is 1.706 1.706 2517 06. So that is miles of 1 penny. So we have found so we have converted we have found the height of a penny in miles. So now we just need to multiply with 5 billion pennies. This 5 multiplied 10 to the power of 9. So it will be like 1.70625 6. Multiply 10 to the power 9. So we can simplify this using the rule called the product rule, which means also using the base and the exponent. If we have the same base, we can add the exponent together. -6 -6 plus 9 is 3, and for this, and we just multiply, and we take this and multiply by 5 like normal. But 8.5. That is miles. The 5 billion pennies. The height of 5 billion pennies is this height. So the question A is done, and we move on to question B. In the past 100 years, nearly 500 billion pennies have been made. If all of these pennies was placed in a single stack, how many miles high would that stack be? You can just repeat the same process I've just done, but instead of multiply by 5 billion pennies, 5 multiply 10 to the power 9, you multiply 500 billion, which is 5 multiply 10 to the power 11. They have give one more information. Is 500 billion pennies is equal 500 pennies, and we change it into proper standard form. Is we move to the left, which means add the exponents of base 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pennies. So like I said, you can just repeat the process of a penny and 5 and multiply it, but instead of multiply by 5 billion pennies, you multiply it by 500 billion pennies. Or maybe you can do a simpler way, like before you found 5 billion pennies. Now all you need to do is find 500 billion pennies. There's one way to do this a bit quicker, is using the answer of the previous question. By we see how many times this amount greater than this, which means how many of 5 billion pennies fit inside 500 billion pennies. Not how many pennies in 500 billion pennies, but 5 billion pennies in 500 billion pennies. How many stack of 5 billion pennies in a huge stack of 500 billion pennies. So here we have, by doing that, we take this and divide by this, which is, no, I'm sorry, this is the height of the mouse. 5 multiplied 10 to the power 9 pennies. How many how many times this fit in? So we take 5 multiply 10 to the power 11 divide 5 multiply 10 to the power 9. So like I said, so we take this, put up here and change the sign. 11 minus 9 is equal to 5 divided by 5 is 1, which is 1 multiply 10 to the power 2 times greater, which means 1 multiply 10 to the power 2, which is also equal 100, which means 100 of stacks of 5 billion pennies can fit into 500 billion pennies. So now, because it's 100 times great, because this is 100 times greater, which means the height is also 100 times, or 1 multiply 10 to the power 2 times greater. So you just need to take this and multiply by this, and you will find out the answer. So taking this, equal 10. We, like the product rule, we take the exponent here plus this exponent is 5 multiply, and we take this multiply by this is 8.531258531, and that is the height of 500 billion pennies. You need to find miles. So next, move on to next question. And also the 100 years, it's the same like question A. It's the measurement of time. It doesn't involve anything about the measurement of height, distance of height. The next question, C. The distance from the moon to the earth is about 239,000 miles. How many pennies? How many single pennies? One penny would need to be in a stack in order to reach the moon. So we have another information is 239,000 miles.